Hello everyone. Uh, Good evening everyone. So I'm Ravi Jalal and I am a PhD student at the IIT Bombay. So today we will conduct the live session for the week two for the course of dynamic office structures. So in this week two content, we will solve few problems related to the free vibration of the damped system and as well as for the undamped system. So, before that, if you have any doubt from the last session, we can discuss here. Anyone. Before starting to week two content, if you want any, if you have any doubt, you can ask here related to the last session, week one. Okay, so for week two content, I am sharing my screen so that we can further move. Okay, is my screen is visible?
Yes, sir, visible.
Okay. So in this session, we will solve few problems related to the, as I told you, like free vibrations. So initially, first two questions are like the objective type questions. So we will solve this throughout, like how we each and every aspect, like which one is wrong and which one is correct. So the first question is that which one is the incorrect equation of the critical damping coefficient? Like we have here, we have three options given. So can you tell me like which one is correct or which one is not? Like which one is the like incorrect? A, B, C, D for the critical damping ratio, which is we call YCR zeta, which we call it C critical. Sorry, for the I critical, this coefficient is one. Okay. So can you tell me which expression is okay for the uh, damping critical coefficient? C. Like as we know, the damping equation, like if we go to the damped system, free vibration, the equation normally would be mh double dot plus cx dot plus kx is equal to 0. Okay, so if we want to solve this problem, so first let me do this. We can consider a solution. Let us suppose x is a function of e raised to power lambda t, something, anything, whatever you want, a, b, or any coefficient. So my x that will be a lambda e lambda t, and x double dot would be a lambda square e lambda t. Okay, if I will uh, put these things into this equation of the free vibration equation, so I will get m time a lambda square e lambda t plus c a lambda e lambda t plus k into a into e lambda t is equal to 0. If I will take e lambda t as a common, so my equation will become, and a also, which become m lambda square plus c lambda plus k is equal to 0. So as I know e lambda t can't be 0. Okay, to solve this equation. So what can be 0? That part can be 0. That we can put it equal to 0. Okay, so now I have a equation m lambda square plus c lambda plus k is equal to 0. Now I need to solve this problem. So this is a 2-degree polynomial equation. So we know if this kind of equation is there, like ax square plus bx plus c is equal to 0. So what will be my x? Will be minus b plus minus b square minus 4ac divided by 2a. So as I know, what would be my b? B is here c, a is here m, and c is your k. Okay, so if I will put in the equation, that would be minus ka minus c plus minus c square minus ka minus 4 m k divided by 2m. If I will further solve it, I will get it c by 2m plus minus square root. So that will come c by, I can write it as c by 2m square minus 4m by k by 4m square. So 4 will cancel out, 1 m will cancel out. So that will become x is equal to minus c by 2m plus minus c by 2m square minus k by m. Okay. So now we have like different, like now we need to solve this equation, like we have two roots x1 and x2 for plus and minus. But for the case if you go through the week 2 content, like for the, like we have three type of damping. One is the underdamped, one is critical, another is the overdamped. For the underdamped, my xi is zeta is less than 1. For the critical, xi is equal to 1, and for the overdamped, xi is greater than 1. Okay, so here my system is the, what is my system? Zeta for the critical system. So for the critical system, when it will be the critical system, if I will set it to 0, that term c by 2m square minus k by m is equal to 0. Okay, so if I will put it, so that equation will become, you can solve it further, c square by 4m square is equal to k by m will cancel out, so my c will become 2 under root mk. So one expression is this, this is there, 2 under root mk. Okay, so that is the correct. Any other way I, where I can put this in this, like this is option b. Any other option where we I can put in this another form? So for the another form, let us put omega. Omega is square is k by m. So my k will become m omega square. So if I will put c is equal to 2 square root m omega square, so that will become 2m omega. So that is the one case also. So 2m omega is there. Yes, that is also, that is the option A. That is also correct. Now for another option, like uh, any another way we can put it. If we can put m, if we can replace m with the k, so what we will get? So from here we can represent m is equal to k by omega square. So if I will put here in this equation or in this equation directly, so c would become 2k omega by omega square. So that will come 2k by omega. So that is D option. Okay. So D is also correct. So only thing is left. I can represent, cannot represent my damping coefficient in term of this one. C is equal to 2 square root m omega n. Okay, so these I can represent my damping coefficient in three terms, like three ways, like by manipulating the things, like from interchanging like k omega n, whatever non values are there, I can find out directly using critical, but I cannot represent my damping through this. Okay, so I have a question. Can anyone tell me what is the underdamped system? Difference between underdamped system, critical system, overdamped system? Anyone?
Yeah, under dam system means, what will happen? It'll keep vibrating uh, about, the axis. It will go positive and negative side of the y-axis or whatever x-axis, whatever we consider. Overdamped means what will happen is it will not vibrate. It will gradually come to stop. Actually, let us take a pendulum. It will gradually come to a stop without oscillating about both the axis or the positive and negative side.
No, your pendulum will not come like it is not an example of overdamped. Pendulum is an example of your underdamped.
No, I'm saying that if it doesn't go both ways,
Okay,
I
okay,
meant to say.
yes,
I said, it will gradually come down to a stop
okay,
with
and the
the static position. I just meant, like,
okay, okay.
overdamped is when it comes to a stop without vibrating on both sides, like a positive and negative side.
So anyone knows the example in the real life example for the overdamped system, underdamped system, critical?
Like we can say door damping or something, it doesn't vibrate about a mean position. It slowly comes to a halt. Maybe if it is overdamped, it will
Yes,
gradually, like in a toilet door or something, it will gradually come to a stop. It doesn't vibrate about a mean position, positive and negative side.
yes, yes, yes. And for the critical system, anyone?
It will,
For the critical system, the vehicle absorber, shock absorber, those are the critical
okay.
system, because the critical system is like little bit quick rather than the overdamped system. So in the vehicle, we want that our system like should come to the initial position after some like breaker or some bump in the road. So that's why we use the critical system in the automobile vehicles.
But I'm not getting here. I forgot actually whether it will vibrate about the mean position or not.
No, it will not
Critical
vibrate.
system.
No, no. Only
But
thing.
then there is only, it's more like a overdamped system only in that case.
Yeah, no, not over. Like it will be. It comes to its original position little bit quicker than the overdamped system.
Ah, quicker. Okay, but
Okay.
still the
Yeah.
arrangement is only the matter of time only.
Yes.
But the system is something like
Yeah, you can come.
overdamped only
Yes. But it is quicker, very
because it
quicker.
doesn't vibrate about the mean position. That's what I'm
Yes,
coming
yes,
to
it,
actually.
it is not vibrating. And for the like if you say that critical is like overdamped, if we provide in the like critical damping to the door stoppers, as you give the example for the overdamped, if we provide critical damping to the door stops, then it will come close to the like with very high speed. So then it
Hmm.
will like it will hit someone, so that will
Ah,
lead to
okay,
some. So that's why we provide the overdamped in the door closure. And for the underdamped,
okay.
you give the example like a pendulum. So
Yeah, yeah, correct.
that's the example. So can you tell me anyone like if my damping is like with the damping uh, my response is decreasing with the time, and that is stable also. It will lead to a stability. If I will do my damping in the negative, like less than zero, Am I audible now?
I don't know theoretically if it exists, but it will add to the vibration more, no? If damping is negative.
As you know, the equation of the like of the system damping, like if your system is damped, your equation is like ut is equal to e raised to power minus I omega dt something, and then
Okay.
some a cos omega t, and that b sin omega t. Okay, so if my damping is like negative, okay, so then my system this negative it will become positive, and my response will start increasing.
Yeah, that's what. Correct.
So that's the
Yeah, like a logarithmic decrement, it will increase
yeah, it will be
exponentially.
yeah,
Like an increase, usually it should come down, but
yes,
now it will be increasing.
yes. So
Okay, negative, the opposite of logarithmic decrement.
yes, so that will be increasing, so that will lead to the instability of the system kind of system.
Oh, okay.
So
Sir, negative damping
This
is a real concept or it is just mathematical?
just a mathematical, not a like
no,
in the
no, sir.
real.
This will be. This can happen in resonance condition. No,
Yeah,
it can keep
yeah,
increasing.
resonance condition is a different. Like if there is a damping, then the resonating condition will be lesser. Like for the resonating is different, and damping we use to like there should not be resonance kind of thing, or it should
Yeah,
reduce the response to like not large displacement should be there. Resonance is not like that. It omega is equal to omega, and my system will fail automatically. Nothing. It will increasing with the time, like that. So but you can say like a condition, like it is a kind of resonance, it is same kind of scenario.
same effect. Like we
Yeah,
process same effect. It produce.
yeah.
Sir, here just a small out of this one. I joined just 2 days back, and I know I just saw the intro. This one. I don't know what topic we are discussing, and which session. I don't know this.
So this
This is third assignment of
no,
what
this
it
is
is
for the
actually third
second
or fourth.
assignment, this is for the second assignment.
But I think I don't have that link. The second one, which problem actually?
No, these are the like the different problem rather than the whatever the problems are given in the your assignments of the week 2. These are not same,
Okay.
these are the different,
Can
but
you just show me, because I don't know whether I'm looking at the right one, because I just saw the intro session and I don't know what problem you're. Can you show me the assignment of which one you're discussing, whether I'm
no, I am
in the
discussing
right
for
one?
the week 2 content, and these
Mhm.
are not same for the, these are same similar kind of problems are there, not the same,
Okay.
similar
Okay.
kind of. So you if you will log in on the nptel portal, you will find the week 2
Ah.
content, and then you can log in into this. So
Okay. Okay.
that, so these questions are different, not the same.
Yeah. Yeah. Okay. Okay.
So this session is for the helping like to you can solve your assignment by joining these
Mm-hmm.
sessions.
Okay.
Okay, so next we are moving, if you haven't any doubt, we are moving to the next question. So in this question we have given a different damping ratios. Jai is equal to 1%, 15%, 25%. So corresponding to that, we need to find out the successive amplitude ratio. Like uh, as we know, like when I provide a damping, my system is going logarithmic decrement. So I need to find out corresponding to these damping ratios, what would be my ratio of last, like the initial ui initial displacement divided by the like the first any displacement divided by the last water by I plus 1, like ratio of uh, amplitude, successive amplitude ratio, like not the all, like I take any two, and then what is the ratio of these two. So give a try and find out, like corresponding to these xi is equal to 10%, 15%, 25%, which option is correct.
Sir, actually, I am not prepared actually because only one intro session I attended. I have not gone through the notes, so I'll not be able to.
Okay, no
I'm just
problem.
witnessing. I'm just witnessing, so
Oh,
I'm not responding. So
okay, okay, no problem. If other students are there, they can try with them.
yeah,
So.
okay, okay, yeah.
So as we know, successive amplitude ratio ui divided by ui plus 1 can be given as a e raised to power 2 pi zeta over 1 minus I square. Some of you might be using only this thing, ui divided by ui plus 1 is equal to e raised to power 2 pi zeta. You can use this one also, but you will get different answer if your damping is more than 20%. Like if your damping is less than 20%, you can use ui over ui plus 1 2 pi zeta. And if your damping is higher than 20%, this is a roughly not a like a hard and core, but you will get a different answer because the damping is high, then your amplitude will be difference. Ui plus 1 is equal to 2 pi zeta divided by 1 minus xi square. So you can use for first two part for damping xi is equal to 0.01, not it is a 1%, sorry, not the 10%. So 1%, and for 15%, and for this one xi is equal to 25%. You can use this. Now this is a formulation. You need to only put the values of xi in this system. Okay, so let me put one by one. So first u1, for first xi is equal to 1%, ui divided by ui plus 1 e into 2 pi into 0.01. Okay, divide by, if you want to use both, like this is applicable for everywhere, this is, you can use there, you will get similar answer, nothing like a, like only you can use, but this is like, this is a approximation, so you can use this one for less than or for all size you can use this. So if you will put this value, anyone with the answer for 1%, what is the ratio is coming? Anyone? If you will put, like, let me calculate what is the answer.
1.06, sir.
Let me check. Yeah, it is coming out to be 1.06. For the second one, 15%.
2.59, sir.
Okay, 2.59. And for the third one, you can try with both the formulas, you will get different, little bit difference. If this kind of questions you will get anywhere in the, like some objective type of questions, then you will get the, like, you will get you will get the wrong answer if you will use simplified for the higher than 20%. So for this you need to use 2 pi 0.25 divide over 1 minus 0.25. So what is the answer? Anyone is with the answer?
5.06, sir.
And can you try with the simple formulation? Okay, it is 5.06. And if you try with the simplified, what will you get? You will get, I think you will get, you will get 4.81. Okay, so you can see like how much difference is it. So in the objective type of questions, if there is something like that, then it will leads to your cutting your marks. So be careful with the using these things. Okay, is there any doubt in question 2? If not, let us move to question 3. The question 3 states that for a system shown in the figure, we need to find out the natural frequency and assume small angular rotation about the hinge. Like, what is the natural frequency? Omega n. Omega n would be square root of k by m. Okay, like for the system, mx double dot plus kx, sorry, cx dot plus kx is equal to 0, then our omega n would be k by m. So in the last session we have discussed how to uh, develop, or like how to formulate the equation of motion for the system. So for this system, this is a beam, or you can call it a rod bar. Like in the last class we have done similar kind of problems. So like there is a beam which is hinged at point, some point, let us suppose a. Okay, and which the mass of the bar m, which is equally distributed m. Okay, and we have applied a damper at 3L by 4, and we have a stiffness applied at L by 4, and we are giving a x deformation, or you can say angular rotation, whatever you want. So if I will give a x displacement to this point, so that my beam will rotate about this. Okay, so that will be how much it is, x, and what is this? This is theta. Okay, and how much it will be? Theta would be x divided by L by 4, so it would become 4x by L. So what would be this damping, displacement at this point? So that would be theta multiply with the 3L by 4. If I will put theta, so that become 4x by L multiply 3L by 4. So that will cancel out. So that becomes 3x. Okay. So now what are the forces would be acting on this system? Like a bar, at this it is a hinge. So if my bar try to moving downward, then there is a damping force applied resisting Fb. it here, and then my resisting force from the spring Fs would be applied it here. Okay. So what would be my Ft? That would be C time whatever the displacement is, 3x dot, and Fs would be K time x. And there is an inertia which will be like resisting force developed by the bar when I will give a rotation or something else. So there is a theta rotation, so that it is giving downward, so that rotation inertia would be inertial force I theta double dot would be there. Okay. So if I will take moment about hinge A and do equals to 0, so that length is 3l by 4, that length is l by 4, so that would become as a I theta double dot because it is anti-clockwise, plus fd into 3l by 4, it is also into anti-clockwise, plus fs into l by 4, this is also anti-clockwise. So if I will put, like, I have the value of fd, I have the value of fs, now what is the value of I? So can anyone tell me what would be the value of I corresponding to point A with the center? Anyone know what is the value of I with the for the center? If my bar will rotate about the center, so what would be the I if the length is L?
ml square by 12.
Okay, that would be the ml square by 12. So what would be the about this point, which is at a uh, L by 4 distance from this here? So try to find out what would be this at this point.
7 by 48 ml square, sir.
Okay, let look at this one. Ml square by 12 plus m into L by 4 square. So that would be ml square by 12, ml square by 16. So that would be come out to be whatever you said, 7 by 48 ml square. Okay. So, and what is my theta? Theta is given to me as I have calculated 4x by L, or I can write this equation in terms of the theta, because that is given itself in the question, like angle is small. So my fs is k time x, so x would be L by 4 theta, so I can find out x as a L theta by 4 if my theta is there. So that would be k into L theta by 4. Same for ft, c into 3 into x dot, so that would be c into 3l by 4 theta dot. If I will put these into equation, I will get 7 by 48 ml square into theta double dot plus ft is c into 3l by 4 theta dot into 3l by 4 plus fs is k l theta by 4 into l by 4 is equal to 0. So if I will get it, L will cancel out at each and every point. So that will become 7m by 48 theta double dot, that will become 9 by 16 c theta dot plus k by 16 theta. Okay, so what would be the my omega? My omega would be k by m. So that if I will put what is k, is k by 16, and what is m, 48 by 7m. Okay, so if I will cut it 3, so I will get 3k by 7m is the natural frequency of the system. Okay, is there any doubt in this problem? Anyone has any doubt? If you have any doubt, you can ask me here. Should I move to next question, or you have any doubt? Anyone? Am I audible to everyone now?
Yes, sir. No any doubt.
Okay, so let us move to the next question, which is like now a numerical type question. So let us read the question, what it is saying. It is saying like, for a free vibration test of a single degree of freedom system, mass m is given as a 20 kg, is displaced by a 2.5 centimeter by a hydraulic jet, and then suddenly released. At the end of the 20 complete cycle, the time is 3 seconds and the amplitude is zero point 0.5 second. So we need to find out the stiffness, and then we need to find out the damping coefficient. So can you give a try? Like, first we need to find out the, you can do any of the thing like which are not interconnected. You can find out first the stiffness, either you can find out the damping, but we first need to, for the finding out the damping coefficient, we need to find out the critical damping ratio, xi, zeta, which we call zeta. So give a try. Like, I have a system STR, like I have a system in which a spring, a damper, which is connected to a mass which is 20 kg. Okay, I don't know what is my stiffness and what is my damping, K and C. And if I displace it up to 2.5 centimeter and then release after keeping this M, then release, then after the releasing, this is the initial UI, then after the UI plus 1, sorry, that it is at some point 0.5 second is my amplitude, zero point 0.5 centimeter. Okay, so like my what can be how my system is vibrating, oscillating, like my system is oscillating. So let us suppose I give it 2.5 centimeter. Okay, so if I will give a from here, it is a 2.5 centimeter, and at the end of like nth cycle, not like these are not, let us suppose these are the 20 cycles. Don't go with the representation, like amplitude is zero point 0.5 centimeter. So first find out the damping ratio, Jai. So for the logarithmic decrement, as we have discussed, ui divided by ui plus 1 is equal to 2 pi xi over 1 minus xi square. So here let us suppose my damping would be very less. Let us suppose 20%, first case scenario. So in this I can ignore this to 1. So my ln would be logarithmic decrement ui over ui plus 1 is 2 pi, sorry, there is an n also, number of cycles, 2 pi n xi. So now you have the ui, which is 2.5 centimeter, ui plus 1, n plus 1, whatever it is zero point 0.5 centimeter. You have n is 20. Now you can get it. Please find it. What is the zeta? Anyone with the answer?
0.0128.
Okay. So we are getting our zeta is equal to 0.0128, or says the 1.28%. So that is less than 20%. So that is okay. So now using that zeta, I can find out omega d, because this is a damped system. Now I need to go with the part 1. For the part 1, it is give me the total cycle time is 3 seconds. The total cycles time is 3 seconds, and number of cycles are n are 20. So my time period, so that time period would be the natural time period or the damp time period? Anyone? So that time period would be
Damp.
damped time period. Okay, so that is given to me 3 divided by 20. So what is that? 0.15 second. Okay, so now can you tell me how if my TD is this, zeta is 1.28%, what would be the my time period, natural time period, TN? Anyone knows the formula? How do we get? Any relation? Do you know? Okay. If don't, let's discuss. So that TD is equal to Tn divided by 1 minus xi square. So here, if you will ignore, because your damping is very less, like around 1.28%. So if you will pay, like that, your TD and TN almost similar, almost equal. If don't, then put the value of TD and TN and find out the TN. TN would be TD time 1 minus xi square. So TD, keep it 0.15, and that is 1 minus 0.0128 square. So can you find out what I'm getting? Tn.
0.14998.
So that is similar to nearly 0.15. Okay, like as that is coming out 0.14998 something. So that would be 0.15 second. Okay, so if that is 0.15 second, now I know what is my stiffness. Tn is 2 pi by m by k, as you all of you are aware with this natural time period system. Now you have Tn is equal to 0.15 second. You have mass. Mass is given to you initially 20 kg. Mass is 20 kg. So can you give a try to find out what would be my stiffness? Give a try. Put the value of Tn, m, and k. Anyone with the stiffness?
Is it 35.056 into 10 raised to 3?
35 into
35.05 into 10 raised to 3?
10 raised to power 3. 35.06 into 10 raised to power 3. Are you saying this?
No, 35.056 into 10 raised to 3.
And the unit?
It is
If you put Tn is 0.15 is equal to 2 pi, m is our 20, and we need to find out k. So that would be 0.15 square divided by 4 pi square is equal to 20 by k. Okay, so from here I can find out k. So that would be 20 into 4 into 6 pi square, where 0.15 square. So that is coming, k is equal to 3509.9 Newton per meter. Always keep in mind, when we calculate the frequency omega n or the time period, mass would always be in the kg and the stiffness would be in the Newton per meter SI units. Okay, sometimes students do the mistake, they keep the stiffness in the kilonewton and whatever. and the sometime if you find a question in the mass is given to you in the pounds and something else, so in that you need to take care with the units. Okay, so that is my stiffness, or I can write it as a k is equal to 35 kilonewton per meter. Now I have the k. Now what I need to find out, damping coefficient. Okay, so for part 2, damping coefficient. Okay, so as we discussed, we have k, we have m. So can you tell me what is the expression for the damping coefficient?
C
Anyone?
by 2m omega n.
C by 2 by omega n, 2k by omega n. So we calculated, like in the first question we find out we can represent damping in 2 or 3 terms. So that was the critical damping. So we have one term was that 2 under root mk, that was the critical damping. So what will be my damping coefficient? C upon C critical is equal to xi. So C will be xi times CCR. So that will become 2 xi under root mk. Now put the value of xi. You have m, you have k. So xi is 0.0128, m is 20, and k is 35091.9. So can you tell me what is the value of C? Anyone with the answer? Anyone? No?
21.44.
Yes. 21.44. And what is the unit? Can you tell me what is the unit for the damping coefficient? Anyone here who can tell me, like, what is the unit for the damping coefficient? Like, as I know, mass will be kilogram, stiffness would be the Newton per meter, and the damping would be.
Usually percentage,
No, I am asking for the
percentage of damping.
damping coefficient.
Okay,
Unit for
okay.
damping coefficient. Like in the equation, as we know, mx double dot kx cx dot, everything is in the term. These are the force. Like this is in the Newton, this is in the Newton, this is in the Newton. So your x is the acceleration, k x is displacement, then k is the Newton per meter. So that will become a Newton. Now cx dot is also in the Newton. So how can we it be converted into Newton? Because x is my velocity, meter per second. So what should be my unit for the C? Like normally, like I'm telling you, letting you know how to remember. So C would be, should be Newton. One thing is Newton, and then another thing is the second per meter. So then it will cancel out, so that it force become in the Newton. So my unit would be Newton second per meter. Okay. So be careful with the units, because these are the SI units. Sometime you will get the question in the uh, pound, like unit in the uh, which unit they called, like the pound, foot pound units, FPS system. So in that you will get confused. Like in that Stiffness is given by the pound per inch. They normally give mass. They give in the pound or the kilo pound. So you need to be careful with these things. Is there any doubt up to this point? In all four questions, if you have any doubt, please let me know. If not, then let us move to the next question. In this question, a diver weighing a 1.5 kilonewton is standing at the end of the diving board. So, do you know what is the diving board?
Swimmers use
Swimming
it.
swimming pools.
Yeah, it is normally in the swimming pools to jump in the swimming pools and all. So we have a like, so that is a kind of a cantilever. Okay, the diving board is always is a like cantilever. So and the diver is standing at here. Okay, so his weight is 1.5 kilonewton. Okay, and the diver length or cantilever length is 1 meter. Okay, and the system combined system is oscillating of the frequency, like it start oscillating when you start jump, like it gives some initially displacement on whatever it is. It start oscillating as frequency of 3 hertz. Okay, so we need to find out the flexural rigidity, ei, of the system. Okay, so how do we find out? That is a very
After getting stiffness,
okay. So
we can equate it to 3I by L cube of cantilever.
so find out the stiffness. So how I will get the stiffness? K, as in the previous question, we find out the stiffness with the mass, with the time period. So what is my time period here?
1/3.
1/3 is the my time period. Okay. So my time period is given as T is equal to 1 by F. So that is 1 by 3 second is my time period. So what is the expression for the stiffness? 2 pi m by k. So now you have T, you have m, find out the k. Anyone? Like try to find out what will be my value of k. Anyone with the k? Anyone? You need to put what is the m. What value you have put you the m, so that you can find out k. Is it 1.5 directly or you are converting into the kilogram?
We have to convert it to
673, sir.
kg.
How much? Someone calculate the k. How much?
673.
673 in the unit.
Uh, Newton meter.
No, it is wrong. 673, how? You have taken the G as a 10 or 9.8?
9.81.
Then you are wrong. Try to look into your calculation. Where is the mistake?
Sir, is it 54326.25 Newton per meter, sir?
Yes, yes, that is nearly. Like, that is correct. If I will solve this, I am getting my K is equal to 54328. Okay, I am getting, someone is getting 326, so that may be the whatever the decimal places up to you are considering, so that's why you may get differ. Now you have the K. So what is the stiffness of the beam or the deflection? We can say, if I applied a point load P here, so what is my stiffness for the cantilever?
3I
1L cube.
So that would be 3ei by L cube. So as L is 1, so my ei would be K by 3. So what would be it? It would be 1800 109 Newton meter square. Okay. Is there any doubt?
Sir, in this problem, what if we consider the mass of the diving board too?
Then your stiffness will change.
Okay.
Your time period, like, time period is given to you 3 hours, then your stiffness you have to calculate it with the UDL kind of thing, like
Okay.
how your mass is lumping, and then, like, in the dynamics you will see later how you have two kind of systems. One is the continuous, one is the discontinuous. So you need
Okay.
to calculate mass, and then using that you need to calculate the stiffness. So that is the another way. Okay, if not, then let us move to the another problem. So this is the simplest problem, I think. Like, we have a package, as you know, like, we order something new, nowadays online by from the Flipkart or Amazon. We are getting our instrument or whatever we are ordering, we getting into a packaging. There is some sort of forms are there. Okay, so those what they work, they are work for the stiffness damping kind of system they follows. Like, if my system is fall down from it some height, then it can observe, like, they also design kind of that thing. Like, if my system is fall down at some height, so it should not be damaged, like that. So same kind of system we have, like, we have a box in which we have, like, what we have ordered anything, that mass is amp. So that form, the stiffness is represented by the K by 2, K by 2. Okay, so the stiffness K is given you 9 kilonewton per meter, or the 9000 Newton per meter, and the mass of the object is given to you 4.5 kg. The container is accidentally dropped from a height of 1 meter above the ground. Okay, so after the, like, falling to the ground, it is like, let us, we are assuming that it will not rebouncing, or it is like it is the contact not again bouncing on that. So we need to find out, determine the maximum deformation of the packaging within the box, and determine the maximum acceleration of the instrument. Okay, this is a simple, nothing like that. We have given some sort of condition like a simple any kind of dynamic system, single degree of freedom system, and we are giving some initial condition through a like dropping a uh, like how can we give a velocity to a system. Have you solved a problem with the initial displacement, like if a I have a cantilever, I apply a initial displacement and I will leave it, so it will vibrate about its original position for the undamped system. So can you tell me how I can give a initial velocity to a system? Anyone? Like you always solve like in the practically, can you think like how can I give initial velocity to the system?
At time 0, u equal to 1 meter.
A time is equal to zero, you will know. An actual practical thing. Can you tell me like I want to give a initial velocity at u is equal to like a time is equal to zero, my u dot v or u dot zero has some certain value. How can I give them? Like for the displacement u zero, I will like simply put it, or I will put it the cantilever and then I will stretch it up to it whatever point I want, and then I will leave it. It will vibrate. For the velocity, how will you give it?
Impact can be given.
Yes, impact. Like let us suppose I have a hammer. If I will give like I will hit through the hammer on the cantilever top, so it will give a impact. So from the impact, it will convert it to initial velocity. So from the impact, we can give the velocity. So same kind of problem is this. Like my box is fall down from a 1 meter. So due to this 1 meter, there is some like falling down. There is impact, and due to this impact and this 1 meter height, I have certain initial velocity. Okay. So what is my system? Like mass is m, like is a system in which my stiffness. So this system is parallel or the series?
Parallel.
Okay. So the my total stiffness would be the k by 2 plus k by 2. K equivalent would be k by 2 plus k by 2, that would be k. Okay. So my initial conditions are, so when I'm dropping this one, there are two things. One is that my initial velocity is developed, b is equal to due to height to zh, velocity is developed, and there is an initial displacement due to this weight like mass. If we will like mass is hit the ground, a system mass with certain stiffness that will hit the ground, so that there is some displacement initial due to this mass, so that would be the mg by k, initial displacement. Okay. So u0 is mg by k, and u dot 0 is square root of 2gh. Okay. So find out what is my m. M is given as a 4.5 kg. K is given 9000 Newton per meter. H is given 1 meter. So if I will put U naught comes out to be 4.5 times 9.81 divided by 9000. That will come 0.004905 meter. Can you tell me what is the 2gh initial velocity? Anyone? Like this is simple. 2ZH, H is 1. 4.4.
4.42.
That is 4.42, okay? 2 meter per second. So, do you know the solution of a free vibration? Like if I will give a free vibration to the system, like mx double dot plus kx, or not the mx double dot if you will confuse, mu double dot ku is equal to 0. What is the solution for this? Anyone?
U of 0 into cos omega t
U of 0 into cos omega t, okay?
plus u dot of 0 by omega n into sin omega t.
Okay. U dot of 0 by omega n sin omega t. Okay. So now you have the values of all the values u0, u dot 0 by omega n sin omega n t. How do we get this? Like as we know, the solution of the free vibration equation is the a cos omega t plus b sin omega t, and then applying the initial boundary conditions, we are getting this. In the week 2 content, if you will go, you will find the solution this one. Okay. So now I need to find out maximum response of this system. So what will be how can I get the maximum of ut from this equation? Directly, how can I get the ut? Either there is one way, another one way is that I plot a graph u versus t, like from t from 0 to some part of, let us say, 3 second or 4 second. I will get a curve sinusoidal, like a harmonic type of curve. So that way the peak will be the my maximum. Any other another way from that I can get the value of maximum u?
Amplitude
Yes. So maximum amplitude, what would be the maximum amplitude for this?
square root of u of 0 square plus
Okay. So my u maximum would be u0 square plus u dot 0 by omega n square. Now put the value of both the values. Do you have omega n? You can calculate it. How do we calculate omega n? You have the mass, you have k, so you can find out omega n. You can find out k by m. So please give a try to find out the omega n. What is my omega n? K is given to you 9000. This is given to you 4.5. So it will comes out to be
44.72.
40.472 radian per second. Okay. So now put the value of u naught. You have the u naught value. U naught is 0.004905 meter. You have u dot 0 is 4.42 meter per second, and you have omega n, which is already here. So can you tell me what is my u maximum?
0.1211.
No.
0.0989.
Yes. 0.009. So that will come 0.00916. Is it okay? Is it correct or something I have done wrong?
Yes, it is correct. 0 point, I think it is 10.
Yeah, yes. That's why I have doubted.
Under root 0.009916.
This one. Okay, so that will be, this is in the meter, so that will become as a 9.916 centimeter. Okay, now you have the u maximum. So maximum acceleration, can you find out? Like, we have the maximum deformation, so maximum acceleration, if I have u maximum, if I want to find the maximum velocity, u dot maximum, what I do, multiply with the omega n into u maximum. And if I want to find out the maximum acceleration, I will do omega n square time u maximum. Okay, so you have omega n is the 44.72 square time u maximum is, like, whatever, if you will keep it in the meter, you will get the meter per second square. If you will keep it in the centimeter, you will get centimeter per square. So I will keep it in the meter. What are you getting, anyone? Anyone with the answer? I am getting around 1.198 meter per second square. Are you getting same?
Yes, sir.
Yes, sir.
Okay, is there any doubt up to these 6 questions? Like, we have discussed some, we are discussing normally numerically, which is are most of related to your assignments. So is there any doubt up to this same kind of problems you will have in the assignments? So that will be very helpful to you. If you have any doubt, you can clear it here related to assignment if you have gone throughout this. Now we have a, like, in the normally books and all, you have seen the equation for the underdamped system. You solve these equations, you find out the response. Have you ever seen the equation for the critical damped system?
Critically damped will not vibrate, no. So
Yeah, it will not vibrate, but it has some sort of equation. Like, as we discussed in the, I think, first question itself, like, these are the roots. This one, like, these are the roots for the damped system. So when will my system will be the critical damp? If my system would be zero, this one is zero. So let us write it there, so that for the system mx double dot cx dot plus kx is equal to 0, I am getting the roots. What those? Those were minus c by 2m plus minus c by 2m square minus k by m. So for the critically damped system, what happens? This one would be the 0, this term. So my roots are x1 and x2, two roots are minus ka c by 2m. So now let us read the question. A structure initially at rest is given an initial displacement and left to vibrate. After how much time would the amplitude of the vibration equal to half of the initial displacement? Okay. So we need to find generally the equation of ut, then we can use this equation. So the structure can be idealized as a single degree of freedom system with the mass is given 5000 kilogram and the stiffness K is given as a 20 kilonewton per meter. A damping ratio is given to 1. So if my roots are equal, can you tell me what is my solution of the equation? What will be my polynomial equation? Like if you have different root, two real root, for two real roots which we solved in the underdamped system, if you gone through the week one, your equation solution is yx would be a1 e raised to power lambda t lambda 1 t plus a2 e raised to power lambda 2 t, kind of, if you are n real roots. Now if you have two same roots, two real same roots, so in this case my equation would be ux, whatever you represent nomination you will use, that up to you. Ux would be a1 plus a2 t, or x, here it is x, so that way write it t because our variable is t normally. So t into e raised to power lambda t. Okay, so the ut would be a1 plus a2 t, and what is my lambda or the roots x1 and x2? That is my c by 2m into t. So this is the my equation for the critically damped system. Is there any doubt in this equation? Anyone? Do you have any doubt? And here, how, what I can write? What is my c by 2m? Can anyone tell me? Am I audible now? Everyone?
Yes, sir.
Okay. So how can I write c by 2m? What is my c?
Zeta into omega n.
2 xi m omega n. Okay. And what is my 2m? So that 2 will be cancel out. So someone is told me I can write it zeta into omega n. But here my system is the critically damped. So my zeta will be 1. So that will become omega n only. Okay. So the my system ut becomes a1 plus a2 times t into e raised to power omega n time t. This is the my equation. Now nothing left in this question. Initially, like there is some initial displacement. I need to find out what are those things. So initial displacement u naught, u0 and u dot 0. So they have given the initial displacement, not the initial velocity. So u dot 0 would be 0. Okay. So if I will put for t is equal to 0, my u0 would be a1 plus a2 times 0 into e into omega n times 0. So that would become 1. So my a1 is u0. Okay. can you find out the u dot t so that we can put the equation? U dot t. Anyone? Can you do the derivative of this equation so that we can easily find out the a2 also?
A2 omega n e power omega n into t.
But you are telling me the like the differentiation of this equation or the a2 coefficient value. Okay, let us do the derivative of this. So let us keep, this one is I am keeping u1, this is keeping u2. So e minus omega n t, and this become a2 plus this will a1 plus a2t, and if I will do this, e minus omega n t time minus omega n, this is my derivative. So at t equal to 0, this becomes 0, like I am keeping it equal to 0, so that e minus omega n times 0 into a2 plus a1 plus a2 times 0 e omega n into 0 into minus ka omega n. So that will become 1, so that is a2 plus that will become 0, so that become a1 time minus omega n. So what is my a1? My a1 is u naught, u initial 0. So my a2 will become here, a2 becomes omega n u0. Okay, so my ut, if I will put the a1 and a2 in this, so my ut would become, a1 is the u naught 0 plus a2 is omega n u naught 0 times t into e raised to power minus omega n t. If I will keep it u naught outside, 1 plus omega n t into e raised to power omega n t is ut. So this is the equation of motion, like solution of the equation for the critically damped system. So now we have given a condition. So what is that condition? That condition is given, we need to calculate the time, like after how much time would the amplitude of vibration be equal to the initial displacement. Okay, so let us suppose at some time t1, at some time t is equal to t1, my ut1 should be equal to u naught divided by 2. Okay, so if I will put this into the equation, this one, it becomes u naught by 2 into u naught into 1 plus omega and t1 into e omega and t1. So u naught will be cancelled out, so that will become 1 by 2, 1 plus omega and t1 e raised to power minus ka omega 1 t1. Okay, so now you need to calculate the what is the value of omega n. Up to this, is there any doubt? Now if we calculate the value of omega n, then you can solve the equation, you can directly get the T1. Can you tell me what is the omega n using this? What is omega n? Anyone? You have given the mass, you have given the K.
Two? Is it two?
Yes, is it 2? So that would comes out to be 20 into 10 raised to power 3 by 5000. Okay, so these will be cancel out this one, so that will be 4, so that will be 2. Okay, so now our equation becomes 1 by 2, sorry, 1 by 2, 1 plus 2t1 into e raised to power 2t1. Now you can solve this into calculator. If you know how to solve this kind of equation, shift plus solve, if you know, then solve it and find out the t1. I'm giving you 5 minutes, find out the t1. Solve this equation. 1 by 2 equal to 1 plus 2t1 into e raised to power minus ka 2t1. So find out the value of t1, so that at this time period t1 you will be having the displacement equal to 1 by 2, whatever this time period is, that initial displacement, it will you not by 2. Anyone with the answer? Because these kind of equation to solve the calculator, you should know. Like you can write your equation, this equation directly in your calculator. If you have like a like calculator fx 991 es kind of this calculator, you can solve the equation. Anyone? One way is this, another way, if you can, like you can make a plot also, then you can find out the answer. Like your function 1 plus 2t1 into a raised to power minus 2t1 is satisfy 8 is equal to 0.5 is equal to 0.5. That value t1 is give you the, that is your t1 value. So here I solve this by using the calculator directly, this type of calculator if you have. and I'm getting the value T1 is equal to 0.8391 or 0.84 second. So you have any doubt? हेलो.
No, sir.
हाँ हाँ, अभी करता हूँ आधे घंटे में बस. हाँ, तबे तबे सही है. नहीं नहीं, और तो कुछ नहीं. अच्छा, मम्मी तो घर पे रहेगी तो मम्मी को कर लो या फिर. अच्छा अच्छा. हाँ ठीक है ठीक है. Is it okay? If you can put 0.84 in the equation, you will get 0.5. Any doubt?
No, sir.
Do you know everyone how I solved this equation in the calculator?
Yes, sir.
Okay, that's good. So now we are moving to the last problem of this session. So
Sir, which calculator you used actually? What
that
type of calculator?
that use FX 991 ES plus calculator. This
FX991
991
ES.
ES plus, that one.
Okay.
So
Okay.
you can use this type of if calculator to solve the equation. Now we have the last question is that we have a mass block which is connected to a spring, and the mass block mass is the 5 kg, and the spring stiffness is the 15,000 newton per meter or the 15 kilonewton per meter. A bullet weight is 0.2 kg is fired at a speed of 20 meter per second into the block and become embedded like it bullet is stuck into the mass box itself. Okay, wooden block in the block. So we need to determine the equation of motion, like resulting motion of the block. So the equation is simple for this. Mx double dot plus kx is equal to 0. This is the equation. Solution of this equation, as we all know, or let me write it in u so that you should not confuse with the whatever in the content, and that mu double dot plus ku is equal to 0. So the solution of ut was u0 cos omega t plus u dot 0 by omega n sin omega t. Omega n refer to the natural frequency omega. Okay. So can you tell me what are the initial condition for this? In this question, only the initial condition is important. Everything is same, mass block, and then everything is same. So if I fire a bullet which weight is 0.2 kg and this mass is 5 kg. See, if after firing, if this bullet is embedded in this, so what is my total mass system become? 5 plus zero point 0.2 kg, 5.2 kg of the mass. Okay. So, and after firing, my bullet is in this system. So momentum conservation system, like moment will be same before and after. So like same kind of things is there. Like if my mass m1 is there which is moving at a speed of v1, and there is another stationary mass m2 stationary. If that will hit to this system, what will be my equation for this? Like then both the mass after hitting that, both the mass m2 and m2 plus m1 will start moving with the velocity of v2, some sort of velocity v2. Okay, so what is my momentum equation? m1 plus m2 into v2 equal to m1 v1. Okay, so here my m1 is the bullet mass, which is mb into v1 mb, and m2 is the wooden block wooden block time v2. Okay, so I need to find out v2 because v1 is given as a 20 meter per second. So can you find out the v2? Like moment through the momentum conservation, can you find out the v2? Like v2 would be mb divided by mb plus mwb into v1. Or v2 is what? v2 is nothing. v2 is your u dot 0 initial condition for the block. So your mb is the bullet mass, which is the point 2 and point 2, and the wooden block is the 5 kg, and the speed is 20. Can you calculate what is this?
Point 0.76.
Okay, this is coming around 0.769 or 0.77 meter per second. Can you tell me what is my u0?
0.
That would be 0. So if I will put the value in the equation, ut is equal to u naught 0 by omega, sorry, yeah, if I will put the equation, so u naught is 0, so that first term will be u0 cos omega t plus u dot 0 by omega n sine omega t, so that would become 0. So what is my omega n? Anyone? How I will calculate omega n? By using both the mass or only single mass?
Both masses.
Okay, then find out what is my omega n.
Stiffness value, sir.
What? Okay,
Stiff.
stiffness is given to you as a, where is the stiffness in the system? Yeah, stiffness is given 15,000. So that is
53.708.
53. 15,000 divided by point.
5 point.
What happened? Anyone? Someone has doubt? Yeah, you were correct. That was the 53.708 radian per second. So what is my ut? It becomes u naught 0 is the 0.77 divided by 53.708 into sine omega t. So if I will simplify that expression, so that would comes out to be 0.0143 sine omega t meter, or I can write it into the mm, 14.3 sine omega t in mm. This is my expression. Okay, so that was our last problem. So now if anyone has any doubt in all the 8 problems, you can ask me. We can discuss it here. I'm here for next 15 minutes. So if you have any doubt, you are welcome. Anyone go through the week 2 assignments?
First I tried, sir, but second yet not. I have tried not.
Because tomorrow is the last date, I think, for the both the assignments.
Yes,
Yes,
sir.
sir.
But now you would be able to solve the second and first assignment because the problem levels are nearly same for both the weeks. So now you got the link of the last session also, like recorded video, and the notes also. They have uploaded. NPTEL team has uploaded on the that portal. If you go there, you can find the uh, problem solving session name in the bottom in the sidebar.
In the discussion side.
No. In the main where they mention the week 1, week 2, week 3, in that that side, that bar, there is in the bottom there is a name, problem solving session. So you can access this from there.
Okay, sir. We will check.
Yes. So if you have any doubt, any of you can ask in the all the 8th question or the from the previous one which we have discussed, like the week 1 content, if you have any doubt. Because this week content is totally focused on the free vibration system for the damped and the undamped. So from the next week onward, we will start the uh, force vibration system for the damped and undamped as well. So in this we have discussed the one question for the developing the finding out the natural frequency. So same kind of in the last week we have discussed 2 problems where we developed the equation of motion. So from that these 2 things also you can find out the natural frequency omega n k by m. In the last 2 or 3 problems were there, so you can find out. Komal, are you able to find out those problem session? Are you able to find out those session link that Google Sheet access?
Yes, sir. Yes, sir.
Okay, then it's okay. So and you got the notes also. I have uploaded this notes with which I have taken during this, and as well as I am uploading some kind sort of PPTs that I have made earlier. So that is also same. So that contain all the solution in the by step. You can go through by both by this lecture notes or the slides. So you will be have the access about this file.
So in the first assignment, there was one problem, like in the triangular shape it is given, and for that I need that value of I.
So you can
Means it
find
is,
out you can find out the triangular bar on the Google, you do it, or else you know how to find out the I, that is some density rho r dr square, something kind of that system. So you can go find out the I value, and then it is easier. Once you find out the I value, that I think nearly uh, ml square by 2 would be the I value, I think. You can go with the process, you will find, but I remember for the triangular shape it should be ml by 2, ml by 2
Okay,
or the
sir.
ml square by 2. Confirm it, I am not sure. Okay,
Okay,
don't
sir.
rely on this the final answer. Any other difficulties in the assignments? And if you have any questions, you can reach me through the discussion form as well. I am there also to answer your questions. If not there, then the next week when we conduct the session on the 15th, I will be there here to give you the answer of your questions. Anyone, if you have any doubt, you can stay here.
Thank you, sir.
Is there any comment or suggestion? Is there any improvement needed from my side, so that would help you to better understanding?
No, sir, it's fine. Everything is fine.
Okay, that session was good. Really, it is understanding now.
Yes, sir.
Yeah, the presentation is very good. Sir, where I can get the link in the same? Uh,
From the NPTEL portal, when you log in
okay,
your section, you would be
okay,
able to see the week 1, week 2 content. Are you able to see that?
okay. Yeah, yeah.
So from there is a link also, problem solving session.
Oh, okay, okay. So all these notes will be there.
Yes. So
Okay,
now
okay,
there is a content for the week 1, and I will
okay,
upload it after some time. So you will get it.
okay,
That will get updated.
okay. And for writing this, how you, which software you use actually? This writing so quickly in the
I'm using tab, so that's why I'm writing.
which one? SAP.
Not a tab for the writing purpose, no.
Oh, okay, okay, okay.
that
Okay, okay,
that you can buy. There is two kind of pads. One is the like writing, you can't see in that pad, you connect it through the USB your laptop, and you will get it. So that will cost around 3 or 4,000 nearly. The
hmm,
another way is to buy some tab, like whatever you can afford, and using that you connect it through the Google, through the Meet, and then you can do that.
okay.
If anyone has any doubt, they can stay here, otherwise they can leave.
Yeah. Anyway, only I have to read actually. Just saw the intro. Now, just 2 days ago I joined actually. I
Okay.
have to go through and no, refresh whatever I have done long back actually for
Oh,
the course.
yeah, but tomorrow is the last date to submit the
Yeah,
assignment.
no problem. Any problem. No,
So,
no. Whatever I know, I'll just submit.
yeah,
Yeah.
no, if you go once through, like you have attended the session, then most of the problems I think you will be able to answer.
Mm,
Or like for the last week, same, you can go through the notes or you can go through the lecture. You will surely you will be able to answer, because you need to only the recall the things, not to go through all the deep. So that will be fine.
mm. Already I had done my masters long back. 94 I completed actually.
Oh, okay. So now what you are doing?
Now I'm working with KBR, Kellogg Brown and Root in Abu Dhabi.
Okay,
So now I am in the working for the client PMC, project management consultant. PMC, as a PMC we are working,
okay.
reviewing documents and approving and those kind
Yes,
of
yes,
things.
yes.
I lost touch actually because, but I'm not. I'm not lost. Really, I will not say I lost touch. But again,
Yeah, that is
such a long time.
coming
Yeah,
back to
so,
these things, like obviously it is
yeah, yeah,
like
yeah.
some
I
sort of
remember. that I have to get back my speed and the solving equations and other thing.
Yeah, that needed.
What happens in industry? What happens is we don't get much opportunity to go deep into the problems. Only
Yes,
we are rushing up in projection schedules and other thing. No?
yes,
So really
everything
don't
is
have.
everything is read in
Yeah,
the Excel and all those things. You need to go there and then update all those things and whatever requirement
yeah,
for the design and all.
yeah.
So I understand those things.
Yeah. Anyway, thanks. Nice interacting with you. My pranams to you
Okay, okay.
for teaching us so nicely.
Yeah,
Nothing. Okay, sir.
thank you. Okay.
Thank you, sir. Thank you.
So here I'm concluding the session. Okay.
Okay. Okay, sir. Thanks to you.
Okay.
Thanks. Bye.
Okay. So I'm concluding the session.